finding an equation using a slope relationship for parallel lines. Well, what we've got is we've got an equation, and we're going to graph that equation, and we're going to graph another equation that goes through the point 1, 3. Well, the first thing I'm going to do is I am actually going to get this first equation, I'll call it equation number 1, into slope-intercept form. What this will do for me is this will enable me to identify the slope of equation number 1, the graph of equation number 1. The slope of the other graph must be the same because the lines are parallel. Lines that have the same slopes are parallel. Here we go, equation number 1. I'm going to isolate for y, so I'm going to add the additive inverse of 10x to both sides, which is negative 10x. This results in 5y being equal to minus 10x plus 20. Next, what I'm going to do is I'm going to divide both sides by 5 to isolate for y. Everything divided by itself is 1, so I end up with y equals, well, minus 10x divided by 5 is minus 2x, and 20 divided by 5 is 4. So equation number 1 in slope-intercept form is y equals minus 2x plus 4. Oh, sorry. Next, what I need to do, so I prepared a graph, and I'm now going to calculate a table of ordinate pairs, x and y's. I'm going to do 3 values of x, 0, minus 2, and plus 2. I'm going to include 0 for x because that tells me the y-intercept. When x is 0, well, anything times 0 is 0, so minus 2 times 0 is 0. So what I end up with is y is equal to 4. When x is minus 2 times minus 2 is plus 4. 4 plus 4 is 8. And when x is 2, minus 2 times 2 is minus 4. Minus 4 plus 4 is 0. I now have 3 points that I can plot. Well, now I've got the points on my axes. I'm going to connect the points with a straight line. I'm going to put arrowheads on the line to indicate that the line goes off in infinity in either direction. So the original question, what I wanted to do was find the equation of a line that is parallel to this first line, which is y is equal to minus 2x plus 4. I'm going to label that right on the graph. Y equals negative 2x plus 4. And I need to find the equation of a line that's parallel to this line. So what I'm going to do is I have to identify the point that this line, this new line will go through, and that point is 1, 3 right here, 1, 3. Come back, and I'm going to use that information. So what do I know? I know that for equation 2, this unknown equation, this is equation 1, equation 2, the slope will be equal to minus 2 because this second line is going to be parallel to the first line. I know that it's going through the point 1, 3. So that means my x value is 1, my y value is 3. So now what I'm going to do is I'm going to use the standard form of the equation for a straight line, y equals mx plus b. Well, my y value is 3. when the slope is -2 and the x value is 1. Now I'm going to calculate b. b, remember this, that is the y-intercept. That's the value that y has when x equals 0. So for equation number 1, for example, the y-intercept is 0, 4, because that's the point at which the graph touches the y-axis. I'm going to calculate that for equation 2 because I need that piece of information to complete the equation. 3 equals -2 plus b. I've solved for b, so I add 2 to both sides, and I end up with 5 equals b. That means equation number 2 is going to be written as y equals -2x plus 5. So that's equation number 2. Well, I'm going to create a table of ordered pairs for equation number 2. Go. X and y, 0, 2, and -2. When x is 0, y is 5. When x is 2, -2 times 2 is -4. -4 plus 5 is 1. When x is -2, -2 times -2 is +4. 4 plus 5 is 9. Now I have some points that I can plot on the same axis. Well, I've gone ahead and I've plotted the points for my ordinate pairs for equation 2, which is this equation set of ordinate pairs here. And you can see that I've got another line, which is in red, which is the graph of the equation y is equal to -2x plus 5. So I'm going to write that. On a test, you need to label all of the equations that you are graphing. You don't have to use color, but you just have to actually indicate which line that you've graphed is for which equation. Notice that the two equations are parallel. Equation number 1 has a y-intercept of 4, right there. There's the y-intercept for equation number 1. Equation number 2 has a y-intercept of +5. +5. So 1, 2, 3, 4, 5. The equations result in graphs which are parallel because they have the same slope, and that's the key to solving this example. Okay, next example 5 is finding an equation using a slope relationship for perpendicular lines. Now the key here is if you have two lines and the lines are perpendicular, their slopes, if you multiply them together, will be -1. So let me just demonstrate this. So here's equation number 1. I'm going to solve this equation for y and identify the slope. All right, so I'm going to call m1 slope for equation 1, which is actually equal to -2. Now I need to find the slope of equation 2. Now the trick here is these are perpendicular lines, and perpendicular lines have a following property. If you have two slopes, m1 and m2, m1 times m2 will be equal to -1, where m1 is the slope of the first line, m2 is the slope of the other line. In practice, this means that if the first slope is, say, well, here's some examples, m1, m2. If the first slope is 1/2, the second slope will be minus 2 over 1. If the first slope is minus 5, the other slope will be plus 1/5. If one slope is minus 1/3, the other slope will be plus 3 over 1. So you have a slope of 2/3 for your first line. The other line will have a slope of minus 3/2. Well, how do I know this? Well, if I take the first slope and I multiply it by the second slope, product will be minus 1. And as it turns out, in all of these cases, if I multiply two slopes together, they're all equal to minus 1. So if the first slope, m1, is minus 2, that means my second slope, m2, will be equal to 1/2. So what am I going to do? Well, I'm going to actually use that second slope, find the equation of the second line. Well, here we go. The second line will have the equation of general form y equals mx plus b. In this case, m is going to be equal to 1/2 because the second line is perpendicular to the first line. And it's going through a point. Well, the point that this second line is passing through is 0 and minus 2. So that means that it's going through 0 and minus 2. So since the line is going through this, that means x is equal to 0, y equals minus 2. That coordinate point, that point is on the graph of this second line. So I'm going to use that information to calculate the equation. Using the standard form of the slope-intercept equation, y is equal to mx plus b. I'm going to solve this for b, the y-intercept. Here we go. Minus 2 equals 1/2 times the x value, which in this case is 0, plus b. Oh, well, that's kind of handy. That means minus 2 equals b. So equation number 2 has the following equation in slope-intercept form. The slope is 1/2. And that's multiplied by x plus the y-intercept, which is minus 2. Putting it in a more convenient form, this is going to be y equals 1/2 x minus 2. All right, so now I'm going to graph both of these equations on the same set of axes. Right, the first thing I'm going to do is create a table of ordered pairs for both of these two equations. Y is equal to minus 2x plus 6, equation number 1. Y equals 1/2 x minus 2 is equation number 2. Here we go. Well, when x equals 0, y equals 6. When x equals minus 1 times minus 2 is plus 2. 2 plus 6 is 8. So when x is minus 1, y is 8. When x is 1, minus 2 times 1 is minus 2. Minus 2 plus 6, well, that's 4. So now I have some points I can plot for equation number 1. I can do the same thing now for equation number 2. For equation number 2, when x is 0, y is minus 2. When x is 2, with once again the denominator of the coefficient in front of the variable is a 2. I'm going to go up and down in increments of 2 here to avoid fractions. So when x is 2, 2 times 1/2 is 1. 1 plus minus 2 is minus 1. And when x is minus 2, 2 times 1/2 is minus 1. Minus 1 plus minus 2 is minus 3. So for equation 1, I'm going to plot the points. So I've plotted the points for equation 1, and now I'm going to draw a straight line. So there is the graph of equation number 1. I'm going to label this graph y equals minus 2x plus 6. Now I'm going to plot the points and draw the line for graph number 2. So now I've drawn the graph for the ordered pairs corresponding to equation number 2. I'm going to label equation number 2 on my graph. And now it turns out that these two, the graphs of these two equations are perpendicular to each other. They are at right angles. And that is because they have negative reciprocal slopes. The graph of this first equation, m1 is minus 2. The graph of equation 2 has a slope m2 of plus 1/2. Just to recap, m1 times m2 must be equal to minus 1. So if m1 is minus 2 and m2 is 1/2, minus 2 times 1/2 is minus 1. So m1 and m2 are perpendicular.